Okay, the unit circle. Unit circle tends to be a very important concept to get down when we're talking about sine and cosine, tangent, all these trigonometric functions. It's really not a horrible concept. All we have is it's going to be a circle that is centered right at the origin. So its center is at 0, 0. And we call it the unit circle because it's going to have a radius of 1. So it's going to be 1 unit to go from the origin to any of these points that are on the circle. Um, when we're thinking about that, the equation of this circle could be written as x squared plus y squared equals 1. If you remember back to algebra where equations of circles are computed, it's x squared plus y squared equals the radius squared over here on the right-hand side. This will come up in a different version very shortly. We also go ahead and say that the length of the intercepted arc, basically the length of this arc around the outside of the circle, is equal to the radian measure of that central angle. So whatever the angle is on the inside is going to be the exact same if it's in radians as far as the distance around the outside, where S is on our picture. So why that comes to be how it is. If we go back to this formula, S, the distance around the outside, equals R times theta, where theta is in radians. In this case, because we're dealing with a unit circle, our radius R is going to be 1. So it turns out that S is going to equal theta. As long as theta is in radians, S is going to be the distance around the outside, and those turn out being exactly equal. Okay, the other thing to look at as we're looking at these is what we sometimes refer to as this point on the circle. So as you kind of wrap around here, this is just kind of a blown up version of the first quadrant. Wherever this point lands, that's going to correspond with an ordered pair, so an x value and a y value. Sometimes we refer to that as being the terminal point. So let me write that in here. That's referred to as the terminal point. And that's going to be a cosine value for the x and then a sine value for the y. Let me see if I can show you real quickly where that comes from. So if we put a point anywhere on the unit circle, and then if we draw a vertical line to the x-axis, what we're doing there is we're creating a right triangle. So when you have a right triangle, the distance on the outside here, if I kind of go from the x-axis to wherever that point is, the vertical distance, that's going to be considered to be y. And then the horizontal distance going across here from the origin to wherever we've drawn the vertical to, that's going to be an x value. So if we think back to what we've already talked about with SOHCAHTOA, if you want to compute sine of that angle t, that's going to be the opposite. So the angle t, is this one's drawn in the first quadrant, is going to be the opposite, y, over the hypotenuse. So the hypotenuse here is always going to be 1 because it's a unit circle. So our sine corresponds with y. Or, as you can see, as we draw these terminal points out, our sine is equivalent to whatever the y value is from that ordered pair. Whereas with cosine, if I want to find what is cosine of our angle t, cosine is the adjacent side over the hypotenuse. So in this case, that's x over 1. Of course, that can simplify down just to be x. That's written out here in this next box that, remember, the cosine always goes as the x value for that terminal point. Sine always goes for the y value of the terminal point. So a couple quick examples here as we're trying to pick out, we're given a terminal point P on the unit circle corresponding to an angle T. And our goal here is just find cosine of T and sine of T. So this is the terminal point 1/2, comma, square root of 3 over 2. So in this case, remember that cosine of T of our angle is always going to be the x value. So it's just going to be 1/2. And then sine of t, sine of our angle, is always going to correspond with that y value from that terminal point. So sine of t in this case is going to be that y value square root of 3 over 2. Now, these may be some values that kind of stick out to you because 1/2 and square root of 3 over 2 come up pretty often. We could use a chart and kind of connect these together, that this is going to correspond with an angle of pi over 3. Or that's equivalent to 60 degrees. So if you plugged in, try to figure out cosine of 60 degrees, that's going to give you a positive 1/2, or sine of 60 degrees or pi over 3, that's going to give you square root of 3 over 2. One more of these real quickly. We have a certain angle, some angle t, corresponds with this point, negative square root of 2 over 2, comma square root of 2 over 2, as it's drawn out in this figure. And our goal is find cosine of t and sine of t. So remember that cosine of t always corresponds with the x value. So we'd say negative square root of 2 over 2. And then sine of t, sine of our angle, is always going to correspond with the y value. So it's as simple as that. It's going to be the square root of 2 over 2, the y value from that terminal point. All right, hope this helps out. So we're getting used to the unit circle and picking out sine and cosine based on the terminal points. Good luck.